when I went to MIT in '94, I went there to study architecture. And '94, if you remember, there was a time when Netscape Navigator was announced. It was the first popular browser. Suddenly I found myself in the middle of this and discovered this thing called the internet. And I found myself in the computer science department as a result. And I studied computer science. And there, MIT, along with Caltech, had the fastest computers in the world at the time. Now Stanford also is doing really well. What you're looking at is System 390, IBM mainframe computer, which was the fastest family of mainframe computers in the 90s until, again, IBM introduced the 64-bit Z architecture, right? And the 967 implementation you're looking at is introduced in '94, and it was right there. The fastest computer in the world was right there in my lab at MIT. And this was no ordinary computer. It had 6 CPUs. Okay, it has 66 MIPS and 2 gigabytes of memory. Okay? Well, you know where I'm going with this, right? This phone in my pocket, this is an A6 chip. And it is said to use a 1.3 gigahertz ARM v7 chip. It has 2,000 millions of information per second processing power versus the 66 megabits millions of information per second for the IBM mainframe. Well, this is an exceptionally fast phone, but any smartphone today has as much power, okay, as what we had back in '94, and '94 was not even that long ago. I find this to be incredibly fascinating that there is 1 billion people that is walking around with as much processing power as an IBM mainframe only about 20 years ago, less than 20 years ago. And this number also happens to be the number of users that Facebook has. Right? And it's not Facebook per se that matters. What matters is the social graph. You connect 1 billion people and give them that much processing power and in their pockets, and that can be very interesting for solving all sorts of problems going forward.